Hey there viewers and welcome back to Planet Cross. We're going to be building a fume extractor here. It's going to be a little cool project to extract some fumes while we're soldering, so join me on the build. Okay, so what we're going to be building here is a fume extractor. I did go ahead, there's parts of the video that aren't going to be recorded just because I actually started this before I started recording. But nevertheless, I do have here the schematic that I kind of drew, or just of all the parts and their dimensions. So what we're going to be working with here is I had an old, I have a lot of spare parts as far as fans and stuff like that goes. So I've got a Corsair, a fan here that we're going to be installing. I actually have two brand new ones. This one on an identical one for a backup. I doubt it's going to fail anytime soon, but nevertheless, I do have a backup. This came actually out of a water cooler for a PC. And so that's what we're going to be using for the fan. I have which is really cool here. I have a circuit board, my first one that I ever designed, and used a software called KiCad. It's a free software program. You download it, you can create the schematic, the wiring diagram, and then go over to the PCB layout and lay out all your components. Look at the view it in a 3D window, which is really cool. And then create the Gerber file and upload it. So I went with JLC. Actually, it's JCL, I believe. PVC.com. So the ordering through them was actually really easy, and I'm actually expecting the delivery within a few more days, so it's already shipped out. So the other thing is, so here's the components I'm going to be using. Obviously, I just showed you the fan. Now this is something that I did pre-make before. So this is going to be the front panel part of it, and actually it's going to be like that. So I got my power input jack, and I do have a power supply that's going to be mounted to the actual box. We just got a basic on and off switch, single pole. So that's all mounted. And then we have a potentiometer. Now this is going to be to control the voltage and the fan speed, because I don't need the fan. I could have just hooked up a basic circuit and just had the fan at 12 volts constantly running at its max amperage. It just didn't make any sense to me, because I don't want to just keep turning on and off, because when I'm soldering I do tend to not necessarily walk away, but I tend to refer back to a schematic or my schematic that I'm looking at or something, or the wiring diagram, and make sure that I'm doing things right, or go ahead and test something else, you know, with a multimeter. So anyway, I put this on here. This is a 100K potentiometer, and this is just going to allow me to control the voltage. Now, I'm going to get to that, and I'm going to get to the circuit board in a moment. But I just want to show you. So I went ahead and just drew out everything, and each component and I went ahead and drilled all my holes, and everything fits beautifully. Um, so that's all set. This is actually going to go on the bottom. Originally I had it designed so it would be at the top of the board, or top of the box that I'm making. Um, but I thought to myself that I don't want to run all the wires down past the filter, even if they're going alongside the board. It's going to make the wires longer and more difficult to fasten to the side of the board, whether I use a fastener or like hot glue or something like that. So I ended up opting just turning this around, and I'm going to lay it on the bottom. We're going to use the bottom of the angle plate. This is aluminum, by the way. We're going to use the bottom of the plate to fasten it with a couple of probably bolts or screws, but we're using MDF board. It's a softer material, so I'm probably going to use boards instead of screws, but we'll see. I got enough board to play around with, and you know what, make mistakes, do it again, but hopefully we don't make any. So here's just a quick schematic. So I got the fan layout. Now here's the my board layout. So it's the exact measurements is 94 or 91.44 millimeters in length, and we got a total width of 35.56 millimeters. So that's my board, and I also created in my board, I'm going to have 4 spots, 4 holes. I think they're 3.2 millimeter holes. We're going to be mounting that to the bottom of the box that we're creating. So I have that, and of course up top, those are dimensions of the on and off switch. That was how I was able to, well, actually, more precise way, you know, take one of these and use it, a caliper, sorry. Because the caliper will do it in inches, it'll do it in, that one doesn't do in fractions, but it'll do millimeters and inches. So it's not the best one, but it gets me by. So we get the voltage regulator, which is what I'm considering the potentiometer. That's just going to regulate my voltage. Then we have, of course, our power adapter. So on to the next page. So this is kind of a side view, and this has been updated. Sorry, it has been updated in sort of in my head. This was the original layout. It was going to be longer than it was going to be wide. But that has since changed a little bit. So you can see actually the ones that I have crossed out there. So those are the dimensions that I'm going to be using now. So of course, so we go over here, we got our carbon filter that I'm going to put on. That whole piece is going to be cut out. Now I don't have a spot where it actually is showing where the mounting plate is going to go with all the on-off switch and the power input, but it's actually going to go down here on the bottom. So this cutout is going to go towards the top, and so the other thing that what's going to happen is my circuit board is actually going to get turned the other way for sideways, but because it's not very long. So in the back is the fan, and yeah, so I did all the measurements, and it took me a little bit. I don't do this daily. So here's the front. Here's kind of the idea for the front. I thought the on and off and the power and the voltage control, the potentiometer there, I all thought that was going to be a lot nicer looking if it was on the top. However, that kind of changed, and like I said, it's now going to go down on the bottom. And the reason why I have 2 measurements here, in case you're wondering, is this was my first attempt, and then because I bought other angle iron, and it was it wasn't as tall, so I went with the larger angle iron piece. So that's why you see 2 different things here, 2 different measurements. So that's kind of it in a nutshell as far as the schematics go. Like I said, I did go ahead and already mount these. I don't, as of this point, I don't have a reason to take these back out. However, it's not an issue. So what I'm going to do is actually show you a little bit of the KiCad. I'm just going to screen record that and show you a little bit of the KiCad because I think that's pretty interesting. Now I'm not going to go through and you know, walk anybody through because I'm even new to it. But I'm just going to show you how I did it. I'm sure some things could have been better, or the board layout could have been a little different. Now the other thing too, so I'm using a couple different components and the voltage control. So actually, what I'll show you here first off, if I can get over here, it's kind of a small room. So what I'm using is basically like a laptop power supply. So, you know, obviously this is going to be, you know, your input. So that's just going to go right in there like that. So this is going to sit on the bottom. I'm going to wrap this around the side of the box and keep it nice and tidy. So the other thing I wanted to mention about this is, yeah, so it's like a laptop power supply. So this is spitting out 19 volts roughly. It can produce up to 3.42 amps, which is way more than I need. So the other thing is what's going to happen here is, so this circuit board that I've created, so I got 19 volts going in, then it's going into a voltage regulator, which is an adjustable voltage regulator, which is dropping it down to about 16 volts roughly. And then it's going to go through a power transistor, and that power transistor is also variable. And I have the, just going backwards a little bit, the voltage regulator is a not only an adjustable, like I said, but I have a little pot on that potentiometer. I'll show you. This was kind of my just quick design here I put on. This one's kind of loose. So these are gonna have heat sinks. But anyway, here's your power, and it's gonna go through a 1 amp fuse, or actually less than that. It's I think we're gonna go through a 0.5 amp, 500 millivolt amp. So there's a little pot right here that you can turn. That's going to adjust this guy right here. All right. And that's going to be my input. So like I said, I got 19 volts going into him, but coming out and going over to my my other guy here is going to drop it down to about 16 volts. And coming out of there, there is about a 4-volt drop just coming out of this one going to the fan, and the fan needs 12 volts. So that's why I need 19 volts. I need 19 volts so I can adjust it down and adjust the output of the power transistor. So it's pretty much exactly 12 volts. So anytime my potentiometer on here is without resistance, basically fully open, right? The valve is fully open, if you want to call it that, but there's no resistance. So with zero resistance, it should be right at about 12 volts. And that will give me the ability to now create resistance as I turn it down, which is going to reduce the voltage going to the fan. And there is a limit for the fan, so you could drop it all the way down to 0 volts. That's basically off for the fan, not for the circuit, but for the fan. The way you turn the circuit off is going to be through this on and off switch, and of course ultimately just removing the power. So but the fan has a tolerance. It's only going to go so low. So in other words, if I had this all the way to 0 and I start cranking it up, it's not going to, even right there, it's not going to turn on. It's going to have to get to a point of, if I remember right, it's about 3.5, maybe 4 volts that it has to reach for the fan just to start spinning very slowly. And if we go midway through, it's going to increase the voltage. You're going to get to 8, 9, 10 volts, and you're going to be at about half the revolutions that it can produce, or half the amperage that's going to produce. So, yeah, that's kind of neat. It's nothing extremely difficult to design and build, but this is kind of an exciting project just because I got a potential PCB board that I designed myself, and uh, having that work is going to be really nice. Now, this um, this power transistor does produce a lot of heat. Now, the further your span is from the way that this kind of works, is that as far as why this big black thing is on here is a heat sink. It's because that power transistor gets very hot and it needs something to cool itself. So we're going to have not only the heat sink on it, but we are going to have airflow going over it, because the fan is going to be pulling air through the filter, which is going to be going across this heat sink. Not this particular heat sink, but we are installing these Mammy Jammies. And these are pretty good. So I think these will go up to 6 watts. I'm only going to be producing about 3 watts total. So this is double of what I really need. So, yeah, the further gap you are, so like I said, if my input power is getting reduced to 16 volts, there's a 4-volt difference that I have between these two guys. And the bigger the distance, the more that this has to work, which gets hotter. So the closer you can get, that is nicer. But yeah, so I'm going to have 2 of these guys, one on each the power transistor, and we're going to have one on the voltage regulator. So we're going to have 2 of these. Now, the circuit board that I designed, it was very difficult for me to figure out how to mount. I mean, I got the 2 MOSFETs, or MOSFET. I got the one MOSFET and the power regulator. Those are on the board, and the holes and everything is fine. I believe it's going to be fine. I haven't gotten the board yet. I'm still waiting for it. But these have also anchor pins, right? So those are anchor pins on there. But I wasn't able to find a heat sink within the KiCad creator to actually mount these on the board. So since the board's not getting moved around a lot, and it's going to be mounted, what I'm going to end up doing is pulling these pins out or cutting them off. They should pull out because these are press-in pins. I don't know how well you're going to be able to see that, but you can see that the pin goes right into the heatsink itself. So they should be able to pull right out. So I'm just going to have these basically mounted. So what you do is you put a little thermo paste on one side of these, whichever way you want to mount it, it doesn't matter. And then use one of these bolt holes and mount. So the thermo paste is just to make the connection good between these two, and then this will keep it cool. So yeah, if I have to take these pins off, I probably will anyway, but if I have to, I will. So that's that. Now I'm going to show you oh, actually, one more thing. So this fan, I had my eye set on the same size fan, another spare that I had, but it was older. This one's only at 0.28 amps max, so it really runs at like, I think like 9 or 0.19 or 0.21, somewhere in there. That's the max peak it'll output. But I don't have it running on that. So well, actually, that's what it can go up to as far as a peak. It's not going to be running at that constant at 12 volts. So, but the other one was, I think, 0.36 or 0.38, somewhere in there. So it's a lot higher amperage, the other one, which creates more current, which also creates, well, it's also creates The current and the amperage is the same. Sorry, but since it's producing more amperage, it's also producing more wattage. So for the same voltage and but more amperage, you're going to have more wattage, which equals hotter. So I would have been up to about 4 or 4.5 watts continuous, and that just would have been, you know, even hotter. So this is nice. These are actually pretty nice. So I'll just give you a little tour here of the workbench, if I can here. Hang on a second. So I basically have my benchtop power supply here. It goes from 0 to 30 volts and 0 to 10 amps. So this guy's pretty nice. I haven't used it a lot yet. Now in the back there, you'll actually see. So I got this GoPro on a tripod, so I'm not going to move it around too much here, but I'll just point the stuff out. So back here, I actually have a PC power supply that I converted so you can use banana jacks. So I got the 3.3, the 5 volt, and the 12 volt in the ground. And I also have on it, might be kind of hard to see. Let me turn actually this on. So maybe that helped. And I actually have a volt and amp meter that I cut a spot out and built into it. So I've used this once. It works pretty good. So I kind of have a backup, but of course these are fixed voltages. This I can adjust to what I want. I can either do constant voltage or constant current with this. It's not the best one out in the market, but it's the first one I've ever had, because I've always used, now in the past, I've always used PC power supplies. I would just take them apart and basically just use the wires off them. It was kind of dangerous, and I don't do that. I don't recommend that. I never had a problem. I never got hurt by it, but it's not a good practice. So now I have, I think this was like 60 bucks or something like that, 60, 70 bucks. This one I had bought for PC, but I didn't like the quality of it per se. I mean, I didn't like the looks of it and the quality of it for PC that I was building. So I ended up just putting it in a box and ordering another one. And I've also got a multimeter right here. That's just an Ampro. So just in case you're wondering, so this power supply here. Oh no, never mind. That was something else. So anyway, let's go over to the computer, and I'll show you the KiCad, and then we will start the build, the box and assembly, and all the components. I mean, like I said, I did mess up, and I was gonna video this, but I wish I videoed this. That's okay. It's just a matter of cutting it out, using a Dremel. I used a hacksaw to actually cut the aluminum to the length that I wanted. Then I used a drill. I have a drill press that I drilled the holes out with a power supply and the potentiometer, and then I used a hole to drill for the center switch. Then I used a Dremel to make the hole square, or as square as possible. So that's that. So let's go over to the computer. What we got here is right over here, I got KiCad. I'm going to double click on that. That's going to open up this. Now, I've labeled my project. Now, I don't know a lot about this. I've only worked with it once so far, and I spent hours doing this because I had to learn it. But I have all right here is my Fume Extractor project. So, in order to get to the just the actual project, if you will. So that's the .NET. Let's see. So we have right here is the schematic. So the .sch is the actual schematic. So we're going to open that up. Now, right here it looks a little small. That's because it is. But if we just use our cursor, we can use the mouse wheel and extend it in. Now, forgive me, this was a lesson learned. So I should have placed these parts further apart because you can see stuff is overlapping. So that's kind of a difficult thing. But let me see if I can actually just move some of these for right now. And just to get them a little bit out of the way, right? So we can see stuff a little bit better right there. Let me do... I hate when that happens. I don't know why that happens. I haven't figured that part out yet. Like, why does that keep popping up? That's very funny to me. But let me move that out of the way. That's so weird. Oh, there we go. Okay. There we go. That's a little bit better. So, basically, like I said, this is the wiring diagram. Here's my input, right? Now, I have some connectors that are pretty universal. I have a few different choices, and this I put in the schematic as a screw down terminal, which is fine. I can tin the leads and I can just install them, which is probably what I'm going to do. Otherwise, I do have some connectors I can solder them together and put a different connector in there with where it just actually literally connects, I should say. Just, yeah. So you can see here's the fuse. This is the voltage regulator. So this is my input. Now down here is that potentiometer, that small pot that's going to be on the board. That's the one I was telling you that's going to adjust the output voltage going to my fan control, which is up here. This is the power transistor. So this one is going to be controlled by this pot right here. So I do have also these test points, right? I got a test point here, I got a test point here, and I got a test point here. This is a ground reference. This is my output for the voltage regulator, and this is my output for the fan. So this is to make sure I'm right on track as far as about 16 volts. This one is my output for the fan. This one's going to make sure that I'm at 12 volts, but they work in conjunction. So whatever I do to this pot is going to happen to this. So I can use this for test point, but ultimately I don't even really need this. Unless I'm not getting an output right here, I can go back and test this to make sure I am getting an output. But I would put my probe meter on here if I ever have a problem with a circuit, and put my probe meter here to ground it. And then as long as I'm getting close to 12 volts, I should be getting 12 volts out of the other guys. So anyway, to the fan, I should say. It should be getting, I don't know why I said that. This is the other potentiometer right here. This is pot number 2. And this is the one that's on the front of the case, on the front of that aluminum angle iron that I showed you. So, so yeah, that's kind of it in a nutshell. It's nothing extremely complicated. Now I will show you the 3D model, or first the, let me get it here, and we're going to open up the project for the PCB layout. So here it is. Here's what the board looks like on the system here. It's very neat. This was so cool just to do. And I'm hoping I didn't make a mistake, like I said. But so we got 4 holes for the mounting. You can see all the holes that are labeled number 1. We have our input right here, which is going to be either a screw terminal or a just a connector of some sort. Here's our fuse. It's going to be 0.5 amps. I got two capacitors to level the voltage out for the output and the input and the output of the voltage regulator. And this is actually the potentiometer that's on the board. That's the potentiometer that's going to control this circuit right here, which is the voltage regulator. And the output of that is going to the input of the fan control of the power transistor. So and here's my test point. So the test point up here, right, is for the fan output. The test point right here is for the input of the voltage regulator, and there's my ground pin. So yeah, this is pretty exciting. This is going to be the potentiometer right here. Now, something I do want to note. So, in order to control this fan, I only need the two wires. I'm not doing the fan's capable of PWM, but I'm not doing that. I know it's got four. I'm gonna have four holes here, and I might not have a connector that has 4 pins, but I only need 2 of these 4 pins on here. So you can see one's connected right here to the pin for the fan header, which is the second one in from this side. And this one, you'll see it's got green spots coming in because that's the ground plane coming in. So that's ground. So this was kind of cool. So now the 3D view is actually pretty neat too. So here's the 3D view. Tell me this is not cool. So this is what it's going to look like, potentially. So you got right there's where the fuse goes. I put on there Fume Extractor. There's version 1.0. All right. There's my pot on the board. That'll adjust this guy. There's my fan output header. And this is my potentiometer that's on the front of the whole project. That's what's going to control the speed of the fan by controlling the voltage. So that's pretty cool, I have to say. Now here's the back of it, what it'll kind of look like. Now, this board on here is standard green, and that's the way it's going to look on this program. However, when you go to order it, you usually have options to change the color. I chose white, actually. So this, where all the green you see here is all going to be white. You could go black or blue or yellow, but I just thought white was pretty nice looking. Now, these capacitors didn't need to be this large, by the way. This one could have been a 0.1, and this could have been a 1 microfarad. But I didn't have them, so I just, it's fine that they're bigger. It's not a problem that they're bigger. It's, you just didn't want to go smaller. So yeah, that's it. So we're just waiting for this to come in so I can start soldering everything together, and I will bring you for the ride. Join me in just a little bit. We'll be right back. Okay, before I went too much further with the project, I wanted to show you what I've accomplished thus far. And so I got all the boards, all the MDF cutouts that I need done. This is actually the top right here. The fan and the guard for the fan are installed. I just got clamps on it with some glue, and it's already fastened down. So you can see there is the fan. And even got the front panel all mounted. So I got 3 screws holding it in there. And So this is kind of nice. It's working out pretty good. Looks nice. I did, however, even though I pre-drilled all these holes, I thought I could sink these screws that I had. They are a little bit too long. The screws are definitely too long. But you can see like down there, I got a couple down here that are sticking out a little bit, and that's just the way they're going to be. So I had 2 or 3 that were sunk in. So there's another one that's sunk in. There's one that's not. And I wish I didn't sink them now, but whatever. It's a homemade thing. That's just a lesson learned if I ever did it again. So the other thing too is because when I ran them in, so I did get a crack right here, and there's one other spot that I got a crack, but it should be fine. You know, like I said, once this is done, it's not really going to be moving too much. It's just going to sit on the table. And so basically, we're just going to put the top on it, like so. And this front, I got to come up with some way of just a filter sitting in here, and so I can sort of do a quick removal of it. I don't want to have to take a bunch of stuff apart just to replace a filter. So I got to come up with that. But I'm probably not going to work on this for another day or two. I'm gonna let this dry overnight. But other than that, I got a few more days till I got to work on it. So. Okay, jump shot to the future a little bit. It is the next day, and I have completed pretty much the entire box and the filter, I guess housing, if you will. The only thing I'm waiting on is my circuit board, so I can finalize everything. Excuse the shadow, but so I got this. So this is just some carbon filter. Now this green filter is not the carbon filter. There's actually the black portion back here is the carbon, but this was kind of an all-in-one filter. I couldn't find a carbon filter without ordering one just at the local hardware store. So the outer green is meant for like pet allergies or pet hair or something like that, but it does have the carbon filter on the inside of that. So, and here's the bottom. So just like I described before. Now this is designed so I can just slip this out. It is a little tight, a little taut, but I can slip this out as a unit and use that. It doesn't slip out easy, but I want it tight. So that's it. I got these are all tops all on. The fan is on. So my next the next couple things that I need to do is actually, I'll just slip this out right now. Kind of hard to do this one-handed. There you go. So now there's the inside. So right in here, going lengthwise like this, is where the circuit board is going to go. Now I do have the dimensions of the circuit board. I could, you know, just go ahead and I gotta mount some I forget what they call them, but they're circuit board studs. I lost the name, but anyway, I could do that and then get that all set. Then I gotta take it all back apart, except for the board, but I gotta take this part off and these, and then I'm gonna sand it all down and hopefully get some of these edges a little smoother, and then I'm gonna paint it. So that's the update. There you go. All right, guys, check it out. So the box is complete. I just got through sanding down all the edges because I did use a jigsaw. I don't have a miter saw to get these edges really nice, and I'm hand sanding. So I got down all the little lips, and now basically all I got to do is get all the sawdust off of it, clean all that up, and I'm going to open up the garage door and give it a paint job. So all the hardware is now out again. As you can see also, there is now 4 holes in there. I drilled 4 holes, and what I'm going to do over here is I got these standoffs, and these holes are just big enough to where they're going to sit in there, and I have to pound them in with a hammer, and they'll be tight enough for this project. I don't have to glue these down or anything, but they'll go in about halfway, so that's pretty much just sitting in the hole right now. So I'll pound them in with a hammer. They'll go in about halfway, and then I'll take the, when the board arrives, that's the dimension of the board. It's 91.44 millimeters of the board. The holes are, you know, a little bit into the board, obviously, but the board size is 91.44 millimeters by 35.53. I actually have made a template. I don't know where that actually went. But anyhow, it was just a little piece of paper I made. So yeah, I'm going to give this a paint job here. And I had bought carbon mist. So we're just going to spray paint it. I'm not going to use a brush or anything. I'm going to see how it comes out. So stay tuned. All right, well, here you go. It is now fully painted. I did go ahead and put the standoffs, just with the little screws that are going to go on the board. Those are already pounded in and installed. But, I mean, it didn't come out too bad. So, you know, I don't know why this did this. I think it was smoother there. But, you know, it's just a home thing. It's not like I'm handing this out to anybody, but it came out pretty nice, relatively speaking. So, actually looks like it imprinted, because there's like no clear coat on this, so it's kind of still a little tacky. Not that the paint's wet, but I don't know. So what we're gonna do is just assemble the parts here into it. Well, actually, I'm just going to put the fan on. That's it. So, hold up just a second. All right, guys, we are back. Take a look at this. The box is fully painted. It looks, you know, I wouldn't say amazing, but it does look pretty good. I'm satisfied and happy with it. I did go ahead and reinstall the fan and the fan guard. Protect our little fingers from anything. So the inside, it's kind of hard to tell, but I did go ahead and insert the standoffs for the circuit board that I'm actually expecting in 2 days now. I just found out that it is pretty close. So, yep, so we got the screws in there for the standoff also. And so that's all set. We got our fan mounted. I may have to change this connector on the fan, and I may not. It just depends on, since it's the first circuit board I've ever ordered, it just depends on what connectors that I have will fit in the board with the size holes and spacing with the holes that I made. But I have like 2 or 3 different options, so it shouldn't be an issue. So I may replace this connector. Not sure yet. So there we go. Well, stay tuned for the next one coming up. Pretty much, it's not even stay tuned. It's going to happen pretty instant, you know, because I'm going to cut it. Yeah, just wait a couple more seconds and we'll be done. All right, what is up, guys? We are back. This is like a week later now. I had to actually, well, let's start with this. I actually had to reorder the boards that I had made, but here they are. They look pretty good. I went through all the testing. My previous set of boards, I had a connection problem between the center pin here and the center pin here, between the voltage adjust and the what do you call it, the MOSFET. the power MOSFET. So you can see actually the trace that goes in between the two. So the trace from pin 2 on this one was going, I'm sorry, the trace from pin 2 on this one was going to the trace on pin 1 of this one, and it's supposed to go to pin 2. So that's the only fix that I had to do. But the board came out very nice. I'm happy, I'm pleased. Obviously, I mean, I got, you know, connectivity between all the connections and my ground plane and all that. So, but this is pretty nice. And of course, I had to do a minimum quantity of 5, so I got 4 spares. I don't know what I'm going to use 4 spares for, but hey, they were only $2, but it was $11 in shipping. So, of course, along to go along with this board is all the components. So I got them all here laid out. We got our fuse, and of course right up here, like you saw before, that's where the fuse goes. And it's also got the center punch out for any ones that have it. So this one's actually got it, so this fits pretty nicely. And we have ourselves a 1/4 amp fuse. We should only be drawing about 0.21 amps. So I'm not expecting, I mean, the fan can go up to 0.28 amps. I'm not expecting it to do that. It never did it during the trial. If so, I'll just change it out. I'll change it out to a 1/2 amp fuse, but I should be okay with that. So we got our fuse block, we got our fuse. I have our power connector here. This is just a wire slip in, so I'm just gonna tin the end of the wires and slip those in, and that's going to go right here. So that's that. We got our 2 capacitors for the board. We have our voltage in adjust potentiometer. We have our resistor. We have our voltage adjust regulator. And then we have our power MOSFET. So then I have a few connectors here. I decided I think I'm going to go with this style connector for the fan connector, because the fan connector, as we can see here, well, it's kind of hard to do it one-handed. Sorry about this, but we have our standard fan connector that's on any PC, and the long ends are going to go right in there perfectly fine. I already tested it, so that works out awesome. So we have that, and then we have our little kit here where I got a 3-pin connector. I have all kinds of sizes, all the way from I think 2-pin up to 4 or 5. And so that guy is going to go right in here for the potentiometer. That is part of our front panel. Sorry for the noise. That is part of our front panel potentiometer. So that's going to go to this guy. And we are going to actually, so we got these little connectors down here. So the male side of the pins that goes in the board is all set. That's set to solder in. But however, the female end, I have to actually splice the wires and tin them, and then we're going to go ahead and put these little connectors on, then slip the wires in here, and they should lock in place, I'm hoping. So yeah, so we're all set to get soldering. It looks like this board is the same dimensions as the old one that I had before. And actually, let me just give you a little comparison here. Well, that worked. Okay. So here's the comparison. So as you can see, well, let's do it this way. So as you can see, it might be hard to tell, but you can almost make out right there. There's a, let me get a little pointer here. So get this under the light here and propped up. Maybe I can do this. So the old board, okay, see this trace right here goes from pin 2 all the way over, and then it stops here, and takes a diagonal, goes to pin 1. So that was my fault right here. So on the new board, obviously I corrected it. So I just basically recreated the trace and went to here. Now you can see though that I did make these. These are not ground planes. They're just additional support. Not that I really need them, but I put these style holes in with this outer edge instead of just the open one, which it makes no difference really for this. So yeah, but everything's the same in both of those. So next step is to solder these all together. I'm going to set up the camera and I'm going to solder these together. So keep watching. Alright guys, so there it is. That is the finished product. Yeah, here now. You saw me assemble, and now it works pretty good. So I just plug this in here, kick this switch on. Sorry, it's kind of hard to do it one-handed. Oh, let me do this. That. Now you can see it's off right now. All right, the fan's not spinning. And we're going to use this dial. It only comes on at about 4 or 5 volts, so it's on right now. And I don't know if you can hear it, but that's full 12 volts right now. There you go. That's sucking in pretty good. There you go, there's paper. Paper's sticking right to it. Alright guys, till next time. Take care.